we said matter occupies space, and it means that matter takes up in the society, in the environment that we find ourselves. Matter occupies spaces. If you are sitting there, somebody else cannot just come and sit on your head. The best that person can do is to sit on your lap. So if you have book here, if you are putting another object on that, you will know that it is another object. No matter how a baby will be, bó ti wò kéré tó, a lè jókòó lé lórí. Bẹ́ẹ̀ni bọ̀ ìbá dán o, ọ̀daràn náà pé ó fẹ́ pa mí lọ́mọ. Àbí? So this is telling us that matter takes up space in the environment. Is it the air? Is it the substances we find around us? They are in the environment. Then I also said that matter can be felt. It can be detected. Bí èèyàn kan bá súnú kíláàsì báyìí, a máa mọ̀ pé àlàyé kan ti jẹ wá. You get? Àlàyé kan ti jẹ wá. Bí ẹyin tó ti bàjẹ́ tó bá drop síbì kan, we will know that there is pungent odor. Now, moving from here, we also maintain that matter, which is number 4, it can change state. It can do what? It can change state. That is number 4. It can change state. So the state we mean here is not the state and capital, I get. But before now, I told you we have majorly 3 states of matter. Can we mention them again? The gas, solid, and liquid. So matter can change state, and that is why some time ago, let me tell you this. I went to Ilorin. Ó funny gan lọ́jọ́ yẹn. Wá lọ sí supermarket kan tán pè ní Chupet. On getting there, mo bá wò pé ice cream lélẹ̀ tó wà okay. Pé ó like ẹ̀ bó ṣe rí. So I bought it. My mumu never do. Mo bá gbé sínú bag on my way to Ọ̀tún. Lo and behold, kí n tó dé Ọ̀tún, guess what? Ó ti mẹ́ẹ̀tì, ó ti dàbàṣà. So ó state tó wà nígbà tí mo rà was what? Solid. But eventually, because of the change in temperature, ó ti change sí liquid. Kò tẹ̀ wá look good mọ́. Owó tá a fi ra ẹ̀kọ́ kò ní já sọ dànù, òun la ṣáà manage ẹ̀. So it happens that way. And why does matter change state? What brings about changing state of the matter? What is that thing that brings about changing state of the matter? Changing the temperature. Changing what? So let me ask again. What brings about change in the state of matter? Change in temperature. And that is it. If you have let's say you have water, you put water on fire. After some time, it turns to what? Vapor. It gives off vapor in gaseous state. If you allow it to cool down and eventually you put it in refrigerator, it changes to what? Solid. That is another state because the temperature is changing. The temperature is changing. Okay, the state of matter. Let us learn about the state of matter. The state of matter. Matter exists mainly in 3 states. You know I said that. Now, let's consider solid. The shape of the solid. It is fixed. The shape is what? Fixed. Roots, are we together? Are you sure? Okay. So, for solid, the shape is fixed. Ó wà papọ̀ bí àpẹẹrẹ ẹ wo marker tó wà lọ́wọ́ mi yìí àbí òkúta. So the shape is fixed. Fist. Fist. I think we can have it in tabular form so that it will make it easier for us. We have the state here. We have the shape. Let's have the volume. What again can we have? Okay. So if you have solid here, you have liquid, and if you have the gas. So for the shape of solid, I said it is what? Fist. Fist shape. For the case of liquid, the liquid only have the shape of the container. Check it. Container tí a bá da omi sí ló máa take. Tẹ́ bá da omi sínú bath, ó máa dúró sínú bath. Okay? It has no fist shape. No fist shape. That is for liquid. Okay? Down now. All right. Also for the gas, no fist shape. No fist shape. No fist shape. No fist shape. Show you? Okay. And the next thing is to consider the volume. To consider the volume. Get this clear. This one, solid and liquid, they have fist volume. Fist volume. Fist volume. But for gas, no fist volume. Now, can we simply state examples of each of these? For solid, give an example of solid. Okay, rock. You mean stone. You mean stone. Stone. Rock is also solid. Yeah, but that is the bigger part of the concept here. Wood is also solid. Abi? Your plate is also solid. Iron is also solid. Okay. Example of liquid: water, juice, and milk, oil, palm wine. Example of gas: thank you, oxygen. Example of gas: carbon dioxide, air, nitrogen. Okay. Now, arrangement of gas in physics. Are you there? Baby, are we together? Okay. In physics, matter is made up of every tiny particles called atoms. Can we take it? Let me take it again. Okay. All right, wait. In physics, matter is made up of very tiny particles called atoms. Very tiny what? Particles called atoms or molecules. And this is to tell us, an illustration here is this. Tẹ́ bá wọnú ilé tán ti window ẹ̀. But eventually, ibì kan lù lára pan àbí látojú window or torchlight. Thank you, a good example. Tẹ́ bá ń wo wájú torchlight, á dàbí pé àwọn ẹ̀ ń rí àwọn particles kéékèèké kan. Have you seen it before? So you just see that. It means that tí irú kan báyìí ò bá sí, you will not have seen it. And this what we refer to as small particles, very tiny particles that made up to become matter. And that is why Yoruba will say, ìsún tíntín, ìsún díẹ̀díẹ̀ ló ń di omi ńlá, ló ń di ibú. Small atoms coming together. In chemistry, they will tell you that atom from atom you have elements, elements you have molecules, you have compounds. Abi? Okay. In the case of Mr. Solid, ṣé the particles tó wà nínú ẹ̀ ó wà tightly compacted. Ìyẹn ni pé ó wà papọ̀, kì í ṣe lẹ́yọlẹ́yọ. Take for instance, nínú òkúta àti omi, èwo ló easy láti tètè fọ́n kó tètè fọ́n kálẹ̀? Omi. Because the particles in solid are tightly packed. And that is it. Tẹ́ bá ra ọṣẹ tó jẹ́ soap, bar soap, àti eléyìí tó jẹ́ liquid soap, bẹ́ẹ̀ ṣe máa wà careful kí alright. So the particles in solid are tightly packed and they vibrate slightly in fixed position. But that of liquid is loose. Loosely packed. Yes. Solid, I said, the particles in solid are tightly packed. Yes. They are tightly packed. Look at the desk you are sitting on. It is tightly tightened together. It is compacted. That is solid. Now, you may have some solid that might not be together, but that one in particular, tẹ́ bá mú rice kékeré ẹyọ kan, you will see that small seed of rice is tightly packed together to the point that if you want to break it, at times you may have to use your teeth to break it.
No, sir, I want to collect my meat.
You have, and I said that the particles in the solid vibrate in the fixed position. Vibrate in fixed position. Next to that is liquid. I said liquid. The particles in liquid are loosely packed and move, since they are loosely packed. Bẹ́ẹ̀ bá ń sin adìyẹ tí ẹ kó sínú cage, ṣe pé ó níbi tán lè rìn lọ mọ́ compared to eléyìí tí ẹ kàn dà sílẹ̀ tó dé pé ó di alẹ́ tá ń gbádìyẹ ẹ̀mí o. It is because you not packed them together tightly. That is why they are loose. That is why they can move around. So the particles in liquid move more freely. Take note of that. Move more freely. What is the next one I want to consider now? Gas. Consider the cylinder tá a fi ń dáná lé. Consider the gas cylinder, the cooking gas. Imagine you open the gas, kẹ́ ṣí kalẹ̀, kẹ́ ṣeré lọ. Ìgbà tẹ́ ṣe máa dé, tó bá ṣe omi ni, ó lè dà sílẹ̀ kẹ́ nù. But in case of gas, can you even trace it to the point of you packing it? So it is widely spread. The particles in gas are what? Widely spread. Widely spread and spaced. And spaced. So let me use this as illustration. For solid, you have the particles like this coming together very close. They are very tight. That is for solid. For liquid, you have the particles to be like they are not too close and they are not too far from each other. But in case of gas, it is always far apart, and it is something you can also testify to. Let's assume that somebody pollutes the air, farting also. Bí ẹnìkan tó wà bẹ́ẹ̀ ṣe ń gbóòórùn ẹ̀, another person here á máa gbóòórùn ẹ̀. But if it is water tó bá ń dànù bẹ́ẹ̀, you can kó tó máa dé bí báyìí, you can easily stop it from that side. Abi? Are you getting it? Now compare it to kó jẹ́ ball tó jẹ́ solid náà jù kalẹ̀. You can easily stop it earlier than omi tó dànù tẹ̀sẹ̀ fẹ́ máa park. You know, at times tó bá jẹ́ ibi tó flow, omi tó dànù sílẹ̀, kẹ́ tó sọ pé ẹ lọ mú mop tẹ́ máa fi nù ó ti ṣàn dé ibi tẹ́ ẹ̀fẹ̀ kó ṣàn dé. Àbí? But just imagine that it is a foam or it is something solid tí ò lè fúnra ẹ̀rìn. You will meet it there. But let's now assume that it is gas. Olófin máa ń difficult tó bá jẹ́ pé gas explosion ló ṣẹlẹ̀. If gas explosion happens, ó wà highly inflammable. Ìyẹn ni pé ó tètè máa gbaná. Because bẹ́ẹ̀ ṣe fẹ́ paná bí báyìí, á tún bẹ̀rẹ̀ bí báyìí. The only thing that can easily stop the explosion of gas is to stop the oxygen. And that is why some people will say tí ẹ bá ti rí pé ó ṣe báyìí, ẹ da kíní dé cylinder yẹn bí pot bí any container or towel ẹ fi bò. Have the courage kó tó di pé ó di nǹkan tí pàwọn nìkan mọ́, ẹ fi kíní aṣọ yẹn ẹ fi bò mọ́lẹ̀. And it is practical. Tí candle bá ń jò tóun fẹ́ nu fẹ́ tí ò bá jò tí ò bá kú, if you can just kó kàn fọwọ́ mú kíní flame yẹn kó fọwọ́ mú bí eléyìí, nǹkan tó ń jò nínú ayé ẹ̀ ó ti lọ nìyẹn. So that is about the particles in this theory as state of matter. Now we have the next thing, we call it changes in states of matter. How do we consider change of state of matter? Melting refers to solid turning to liquid. Melting refers to what? Solid changing to what? Liquid. So when you have your solid turning to liquid, we call it melting. Can you give an example of matter that changes from solid to liquid? Ice block. So you have ice block changing to solid, it is called melting. Wọ́n náà sọ pé ṣó ti melt bí àpẹẹrẹ àwọn tá a máa ra ice cream àbí yogurt ní school wa mẹ́rin, àbí tá a bá gbé juice sínú fridge tó bá ti wà solidify, a máa dúró kó ṣe kí ni kó melt ká tó lè enjoy. And you now know one thing, tí nǹkan bá wà solidify tó wà frozen bí sobo àbí any other drink, tí ẹ bá ti ń mu bó ṣe ń melt yẹn tẹ̀ ń mú, at the end of the day ẹ máa rí pé the latter part of the substance kò ní dùn mọ́, omi ó máa jẹ́ omi. Have you seen it before? Have you? Okay. So melting means solid changing to liquid. The next thing is freezing. From the word freeze, kíkan ó freeze kó dípọ̀ àbí. So it means liquid turning to what? Solid. So liquid turning to solid is known as freezing. So there's another one we call evaporation. evaporation, evaporation, evaporation. So evaporation refers to liquid turning to what? To gas. When liquid turns to gas, we call it evaporation. An example is water turning to vapor. Water turning to what? Vapor. Next to this is condensation. Condensation from the word condense. Condensation. The word condensation is the turning of gas, the changing from gaseous state to liquid state. Ìyẹn ni pé afẹ́fẹ́ gas ó wá di omi, ìyẹn là ń pè ní condensation. Bí àpẹẹrẹ, tá a bá ń dáná, kí ni ọmọ orí pọ́ọ̀tù wa, àwọn gáàsì yẹn ló ń ṣe sí òkè ẹ̀. Tẹ́ bá wá ṣí, ẹ máa rí omi ní abẹ́ ọmọ orí pot. It is as a result of condensation. Do you get it? Do you get it? So steam, omi tó gbóná yìí là ń pè ní steam. Omi tó form láti ibi ooru tó ń jáde yẹn. The steam, the gaseous form of water is the steam. Now when it is gas, but it is now turning to water, we call the process condensation. Condensation. And that is why ooru tó bá ṣí pot tó bá ẹ̀ tí ooru yẹn mú ẹ lọ́wọ́, ó jó èèyàn ju kómi gbóná dà jó èèyàn lọ. Has anybody fallen victim of that? So because the steam is at the high temperature, before you can have vapor or steam, the temperature of the water is close to 100 or even 100. You know, before you have boiling point of water. What is the boiling point of water? 100 degree. The melting point is what? 0. Okay. So we have this sublimation. The next change of state is called sublimation. Sublimation means when you just have a solid, you have your solid, turn it to gas without passing through liquid. It is called sublimation. Should I take it again? All right. When solid changes to gas without passing through liquid, is called sublimation. Do you know an example of this? One quick click on the camphor. Ṣé ẹ pé gbàtẹ́ rà lọ́jà solid ni, you throw it inside your box or at the corner of your house. You just realize that kò domi, kí ló dà, ó kàn yọ, ó dà fẹ́fẹ́. It is through the process of what we call sublimation. Ó máa sublime from solid to gas. So if there is any other thing that you can think of that from liquid or from solid changing to gas, then we can mention it. But a good example of it is camphor. Then we have something we call sodium pellets. Sodium pellets solid ni, but tó bá ti wà exposed sí atẹ́gùn kò ní domi, ó máa kàn lè dà fẹ́fẹ́ ni. Next to that, we have the importance of matter in physics. Importance of matter in physics. Are we together? Okay. Importance of matter in physics. 1. Matter helps us to explain how materials behave under different conditions. Matter helps us to explain how materials behave under different conditions. Are you getting it? Okay. So what this means that irú mákà ọwọ́ mi yìí àbí irú ice cream tí mo sọ fún wa lẹ́ẹ̀kan, ó ti jẹ́ kí n mọ̀ pé mo ra ice cream láti Ìlọrin mo gbé wá sí ọ̀tún láì gbé sínú fíríjì láì gbé sínú kúlà ó ti jẹ́ kí n mọ̀ pé erékeré ni mo ṣe àbí. It will help me to understand that alaye na how do you expect the ice cream to still remain solid. This will also help us as obìnrin pé tá a bá ra ẹran àbí ara ẹja lọ́jà n pé ó ní time tó lè dúró dà tá a bá sè tó máa ṣe kí ni tó máa bàjẹ́, because change of state is independent is depending on change in temperature, and that is it. Oúnjẹ tètè máa ń bàjẹ́ nígbà ooru ju ìgbà ọyẹ́ lọ. Why? Because the temperature of the oúnjẹ ní ìgbà òtútù ó wà stable compared to ìgbà ooru. Ìgbà ooru yẹn heat bá ṣe wà bíbà nísìn tó bá di pé à ń sọ̀rọ̀ everybody try láti sọ̀rọ̀ ẹ máa rí pé ooru inú yàrá yẹn ó máa pọ̀, but ibi ìbà ó wà okay báyìí torí pé everybody remain calm, but by the time the kinetic energy in us is working there will be heat, and when there is heat the change of the state will also do what? Vary. So it helps us to understand how materials behave under different conditions. If you have irú in your vehicle, tẹ́ gbé irú tẹ́ gbé travel, àárọ̀ tẹ́ jọ ń travel ẹ lè má ti feel anything, tó bá ti ń dọwọ́ ọ̀sán tẹ́ ṣì wà nínú mọ́tò ẹ á máa fi pé nǹkan kan rùn. Wọ́n lè máa tọ̀ sẹ́yìn ilé wa àbẹ́yìn window wa, àárọ̀ a lè má feel anything, but ọ̀sán tóòrùn ti ràn we start to feel it that so that is telling us that there are different behavior of materials under different conditions. Do you understand? Let me also exemplify this. Tá bá jí láàárọ̀ tá wọ bàtà tá wọ kọ́kọ́ shoe wa, understand? Tá bá wọ kọ́kọ́ shoe tó gbà wá láàárọ̀ tó bá ti ń dọwọ́ ọ̀sán á dà pé ó ń fún wa lẹ́sẹ̀ ń pé a wà comfortable pẹ̀lú ẹ̀ mọ́, ẹlòmíì á bọ́ á kó slippers dání. Why? Ẹsẹ̀ wa ti expand ju tàárọ̀ lọ. You understand? Ẹsẹ̀ wa ti ṣe kí ni ó ti expand ju tàárọ̀ lọ. Okay. Have you experienced that before? Have you? Ẹ̀yin gẹ̀ẹ́sì wa wọ́n lẹ́fi máa ń kó ẹ máa kó pẹ̀kẹ̀rẹ̀ mẹ́sì. Ẹni tó jí láàárọ̀ kùtùkùtù tó wọ stiletto shoe kó kà gbàdá ṣe di ọ̀sán á ti bọ́ sínú báàgì wípé kìíní ti fẹ́ pa àwọn ẹlòmíì gan ẹsẹ̀ lébù in the process of that. Number 2, matter helps us in the understanding of physical and chemical changes. I'm just trying to rephrase it in a way that you understand. Matter helps in understanding of physical and chemical changes. Ìyẹn ni pé, like I explained before, it will help us realize that there are something we call physical changes and chemical changes. In physical changes, the changes are not the same as that of chemical changes. We will get to that topic and we'll do justice on the differences between chemical and physical changes. But you will learn it better in chemistry. Another importance of matter, it forms the basis for studying energy and motion. Matter forms the basis for studying energy and what? Motion. Number 4, it is useful in industries. E.g., manufacturing, engineering, and everyday life. Matter is useful in manufacturing industries, in engineering industries, and many activities that we do every day. The knowledge of matter will help you to understand that tó bá fẹ́ ṣe rice agolo méjì o gbọ́dọ̀ fi iyọ̀ tó àfi ṣe abọ́ kan sí. It is the knowledge of matter Now, in summary, just listen to the summary. We've concluded, we've maintained that matter has mass and it occupies space. Abi? Also, we also made it clear that matter exists in three states, which are, let's mention it together: solid, liquid, and gas. You will also recall that the matter that we are talking about is formed as a result of tiny particles that we call atoms or molecules. Now, each of these states, the particles or the molecules or the atoms in solid, are well and tightly packed. You understand? And they don't easily move around. They only vibrate in a fixed position. Ṣé ẹ rántí? Abẹ́ ti gbàgbé? Alright, I want you to be active. Now, I also maintained this point that the particles in liquid are loosely packed. Wọ́n free there, they move freely. But the particles in gas are widely spread and spaced. You understand? Then the shape. Two of these. Solid has fixed shape. Liquid doesn't have. Gas doesn't have. You understand? Now, solid has specific volume. Liquid also has specific volume. But gas ńkọ́ kò ní. So ẹ fi sọ́wọ́ àlàáfíà yín kẹ́ má fi jẹun. We also discussed that matter can change from one state to another. What brings about change in state of matter? Change in temperature. Change in temperature. Then all matter is made up of what? All matter is made up of, gbogbo matter tá à ń sọ yìí is made up of what? Ẹ má gbàgbé, rántí. Matter is made up of very tiny atoms or molecules. Don't forget that. So let's evaluate ourselves. What is matter? Raise up your hand and talk. What is matter? We are adults. We can't just be giving chorus answer. So should I assume that I've not taught you or you've not learned? Yes, Aishat. What is matter? Clap for her, please. So matter is anything that has weight or mass and occupies space. Mention three examples of matter. Three examples of matter. Somebody raising your hand. Yes. Those are states. Examples of matter. Yes. Pen. Water. Juice. Okay. Clap for her, please. So another person to give three examples of matter. Yes, Mary. Wood, thread, and pen. Yes. Table, rock, laptop. Thank you. Like you have. Okay. Let us state and list the three states of matter. The three states of matter. Who is raising hand up? Yes, Emmanuel. Are you? Boli, okay, Boli. Solid, liquid, and gas. Clap for him, please. Clap for him. Okay, what happens when a solid is heated? When a solid is heated, what happens? Yes, it turns into liquid. It turns into liquid. But in case it is not something that can change to liquid, for instance, wood is a solid, and when you eat it, when it is heated, when it is burnt, it doesn't change to liquid. it doesn't change to liquid. What happens to that? The molecules, the particles in it becomes loose. Ó máa loose. Òun ló fi jẹ́ pé tí iná bá ti lè jó irin àbí any metal, ó máa weak, kò ní strong bí tẹ́lẹ̀ mọ́. Àwọn ló fi rọrùn fún àwọn alágbẹ̀dẹ, the blacksmiths, before they can have access the ease of turning that metal into what they want, they have to do what? Put it in the fire. A ti pọ́n kẹ̀kẹ̀kẹ̀, a ti gbóná. They will now use their hammer to eat it so that it can become what they want it to be. So the molecules in the solid will change, will break, will become loose, Okay, how can we describe two characteristics of matter? Give us two characteristics of matter. Characteristics of matter. Yes, Ruth. It can change state. Clap for her. Another one. It has mass. Clap for her. All right. Now, how can we state difference between a solid and a gas? Is there any typical difference you can mention between gas and solid? Is there any difference? Yes, Rudyard.
Solid is having a fixed shape.
Solid has a fixed shape.
Why gas has
Why gas has no
no fixed shape?
fixed shape. Is that correct?
Yes.
Let's clap for ourselves. I want to believe that we understand this concept better now. If you don't, ask me a question. All we've considered today is basic concept of matter.